Hello, let us solve some question from matrix determinant in the topic elementary row and column operations, rank nullity of a matrix. As you know, any row operation cannot change the rank of a matrix. So for the first question, all of the above, that is, no row operation can change the rank of a matrix. So option D is correct for the first question. And let us move to the second question. If a matrix A is row reduced to its row echelon form, then the number of non-zero rows, you all know that number of non-zero rows in a row reduced echelon form matrix is equal to the rank of that given matrix. So option B is correct. Now let us move to the next question. The rank of a 4 by 6 matrix cannot exceed. So we know that if A is a m by n matrix, then rank of A is less equals to minimum of m by n. Here m is 4 and n is 6. So 4 is the minimum. That is option A is correct. If A is a 3 by 3 matrix with rank A, then we know that the formula rank plus nullity of a matrix equal to n is the number of columns, which is 3 here. Because m is 3, n is 3 also. So if rank is 2, then nullity of A equal to 3 minus rank, that is 2. So nullity is 1. Option B is correct. Next question, elementary column operation of adding multiple 1. So any elementary operation cannot change anything. So neither rank nor determinant. Option D is correct. In this question, this is a row reduced echelon form and one non-zero row. So rank is 1. If the rank is R, then we know that if A is a m by n matrix, then rank A plus nullity A is equal to n. Therefore, since number of column is n, so nullity of A equal to n minus rank is R. So option B is correct. A matrix is said to have full rank if its rank. We know if A is a m by n matrix, then rank of A is always less equal to minimum of m and n. And it is said to be full rank if this is equal to. So actually the minimum of rows and columns. Nullity of a 5 cross 5 identity matrix. So we know that I is a 5 cross 5 matrix, then rank of I equal to 5. Therefore nullity, we know that rank plus nullity equal to n. So nullity equal to 5 minus 5, that is 0. Option A. If A is a 3 by 4 matrix and its rank is 3, we know that rank plus nullity equal to n. N is 4 in this case, number of columns. So nullity will be 4 minus rank is 3. So 1. Option B. Elementary row operation can be used to compute, we know that, inverse of a matrix, because we know if this is A matrix and I matrix, then we use this to find our inverse. The rank of a matrix equals to the number of pivot column. We know that this is a row reduced echelon form. So option B is correct. If A is a 2 by 3 matrix with rank 2, then the system has, so if rank of A, we know that we have two cases. If rank of A equal to n, then unique solution, and this is for the homogeneous case, that is Ax equal to 0, and if rank of A is less than n, then infinitely many solutions. So in this case you can see that n equal to 3 and rank is 2, which is less than 3. So infinitely many solution. Option C. Maximum rank of a 4 by 3 matrix. You know that rank of A is always less equal to minimum of m and n. So it will be option A. If the rank of A is 0, then it will be 0 matrix, because we know that if A is a 0 matrix, then its rank is always 0. Nullity of a matrix A plus its rank is equal to, so this is the rank nullity theorem, nullity A plus rank A equal to n, where n is the number of columns, where A is m by n matrix. If A 3 cross 3 matrix has rank 1, then nullity, again the same formula, rank plus nullity of a matrix equal to number of columns, that is 3 in this case. So rank plus nullity equal to 3, then nullity will be equal to 3 minus rank is 1, so 2. Option C. Row reduction of these matrix gives rank. So let us start row reduction. Let 1, 2, 2, 4, then R2 will be R2 minus 2R1. then 1, 2, and the next row will be 0, 0. So this is row reduced echelon form and 1 non-zero row. So rank of A is 1. Next question, the rank of A transpose A where A is m by n. We know always that rank A, rank of A transpose and rank of A transpose A always are same. So option C is correct. If A is m by 5 by 5 and singular matrix, then its rank is, since singular matrix, that is rank of A will be always less than 5 because determinant of A is non-zero, implies it is a full rank. But given that singular matrix, so rank of A is always less than 5. Option D. The number of independent rows in a matrix defines, you know that this is one definition of rank. So option B is correct. If A is 4 cross 4 matrix with rank 3, dimension of the null space, actually dimension of the null space is equal to nullity of the matrix. So we know that nullity equal to number of columns minus rank of A. So n minus n is equal to 4 in this case and rank is 3, so 1. Option B. Elementary operations preserve the rank always. The rank of a 0 matrix, you know that this will be always 0. If A is 3 by 5 with rank 2, then nullity, again same thing, rank plus nullity equal to n, where n is number of columns. So 5, then nullity will be 5 minus rank of 2. That is 3. The maximum number of linearly independent column in a 6 and 4, you know that this is the rank. Maximum number of linearly independent columns are rank, so which is less equal to always minimum of 6 and 4 because m and n are 6 and 4. So option A. Next we will solve some more question.